Okay, so for the last couple of lectures, we talked about cleaning data and web scraping, both of which are sort of vitally important skills to have and also sort of horrible to do. In this next lecture, we're going to take a look at regular expressions, which is one of my very favoritist things. These are a little difficult to get used to, but once you do get used to using regular expressions, you'll find them extremely powerful and flexible for searching for patterns in unstructured text. Okay, so I'm going to skip those couple of review questions. Regular expressions use special characters to allow you to describe patterns that you want to search for in text. For example, if you're reviewing news articles or Twitter tweets or what have you, you can do sentiment analysis by analyzing the text for various words or patterns. You might use it for something like DNA matching, classifying or searching within documents, and such similar kinds of things. In a regular expression, ordinary characters just match themselves, but there are also a variety of special characters, sometimes referred to as meta characters, that can be used to describe patterns. And in Python, we need to import the RE module to be able to use the standard regular expression matching facilities. Now, regular expressions are widely found in a variety of other contexts. They are available in Java. They are available in the C++ programming language. They are available in Unix/Linux command line utilities like grep and so on. These things are all very similar to each other, but they're not all exactly the same. So what we're going to be talking about here is stuff that's found in Python. A lot of it will be found elsewhere. Some of it you may not be able to use elsewhere. We can search for literal strings in a document by doing a stir.find, but that's really very limited. If you're searching for somebody's name, for example, you might not know, is that name going to have a capital letter followed by lowercase letters, or is it going to be spelled in all caps, or maybe the name for some weird reason is going to be spelled in all lowercase. Rather than looking for specific literal strings, regular expressions allow us more flexibility. Okay, so the two most common functions from the RE library to use, and I'm going to import RE in my shell here, are re.search, which allow me to search for some pattern within some string, and that will locate the first place in the string that matches. If there's not a match, the search function will return none. Otherwise, it returns something called a match object that you can query to find out where in the string the match occurs. There's another function called match, which is similar, but match is restricted to just looking for pattern matches at the beginning of the string. So actually, I think you're better off sticking with search, and you don't really need to use match because you can use regular expressions themselves to specify that you want to look for things at the beginning of a string. You can also use a function called findAll, which will return a list of strings that match the particular pattern that you're looking for. You can use fullMatch, which will return a match object if the pattern that you've specified matches the entire string. Here again, this is something that you can live without. You can just use regular expression.search. because there are special characters you can use to specify the beginning of the string and the end of the string. You can split a string based on some pattern into a list of substrings, and there's a global flag that you can pass to global flag. Well, there's a parameter, I should say, a parameter called flags that you can pass to any one of these functions to indicate that you want a letter case to be ignored, so that both upper and lowercase letters found in a pattern would match. All right, so that's all, pretty high level and theoretical at this point. We're mostly going to be looking at using search to match patterns. Here we have a specific example. I'm going to create a string containing how now brown cow, and I'm then going to do an re.search for the pattern ow in that string s. Now, the O and the W are not special characters, so the O just matches O and the W just matches W, and they have to be right next to each other. When the search function looks through this string s, the first match that is discovered is the OW in how. What I get back from the search is this thing called a match object. The span tells me where the match starts. It starts at character sub 1, and 1 past where the match ends. So it starts at sub 1 and then sub 2, so up to but not including sub 3. And the specific match, which shouldn't be a big surprise, since we're looking for literal O followed by literal W, is this literal O followed by literal W in how. Now, I can store that match object into a variable. So let me re-execute the search for OW in my string S. And then I can use S sub mo.start, which gives me the starting index, and mo.end, which gives me 1 past the ending index, to request a slice from that string. All right, so that's another way I can use the match object to suck out the match. Now, I used search here in this first example, which looks anywhere in the string. If I use match, you might be surprised by the result here. If I say re.match OW in S, I get none, although none by default doesn't display. So let me store that match into a variable and then print the value of the variable to see that it really is none. And the reason for that is that match requires the pattern that you're searching for to be at the very beginning of the string. And since the OW are not the first 2 characters in the string, the match function does not find any match, whereas the search function does find a match. So I think you will probably confuse yourself by using match, and probably should just stick with search. If you want to get all of the matches in a list, you can use find all for that purpose. So let me just say matches gets find all of the occurrences of OW in the string S. Matches now is just a list. This is fine as far as it goes, but this list doesn't tell me where those matches actually are in the string. So I find out that I do have OW 1 time, 2 times, 3 times, 4 times, but I lose any information about where those things are. Full match would only match little OW if the entire string S consisted of just OW, so that also is not going to match. Now, sometimes you want to test a pattern against a whole bunch of different strings. For example, you might want to search all of the strings contained within a text file, or all of the lines contained within a .csv file or something, looking for a certain pattern. On the other hand, you might sometimes want to check many different patterns against one string. If the user types some input that you've requested, you might want to match that against various patterns to try to categorize what the user typed. Maybe the user typed an integer, maybe the user typed a floating point number, maybe the user typed a word, strictly alphabetic word. So imagine, for example, that we have our information in a file and we want to go through and compare some pattern against all of the lines in the file. Here we're just going to print out the lines that match rather than get the details about the beginnings and endings of the match. And we're doing this using a for loop. Okay, although I guess in this case we're just using a list of strings rather than a file. We'll see a file example quite shortly. I do have this my data in this code file. So let me copy and paste this into my shell. Okay. Set up these examples. Okay, so my data is a list of 4 stir values, and if I set my pattern as just the plain character F, F is not a special character, and so when I say re.search for this pattern in some string, let's say my data sub 0, I'm going to search for that string in my data sub 0. Okay, I got no result. That means that what I actually got back was a none, because there is no little f in that sub 0 entry. On the other hand, if I search for little f in my data sub 1, okay, there is a little f in that line, and so I do get a match in that case. Here I'm using a for loop to step through all of the lines, all of the strings contained within the my data list, and I'm only going to print out the ones that do match. Okay, so for row in my data, if the search for the pattern does match the current row, so that what I get back is not none, that is, I get back a valid match object, I don't get back none, I'm simply going to print out the row that matches the pattern. Okay, and so the second string in this list of 4 strings has a little f in it, and the fourth in this list of 4 strings also has an f in it. Find all will give me a list of all the matches, and in the cases where there aren't any matches, I'll get back an empty list, consequently. So let me modify my pattern to TO. Again, no special characters there. I'll do my loop. This time, instead of doing a search, I'm going to just do a print of re.find all of the pattern in each row. Okay, so let me redisplay my data. Okay, so we're looking for TO in each of these strings? Well, there's no TO in now is the time, so I got an empty list back. There's no TO in for all good people. There are two TOs in to come to the aid of their country, to come to the aid of, to come to the aid. And there's no TO in of their country. So notice that I got a list of two TOs from that third row. All right, now we're going to take a look at an actual file, which is Edgar Allan Poe's The Raven. We can take a look at this. I've got it in a text editor. Here we go. Here, I've got it in Notepad. And this is a long and creepy poem. It's famous, and Poe has been dead for long enough that it's no longer copyrighted, so I can use it for examples. All right, so let's give this thing a try now. We're going to search for the pattern Raven. We're going to say with open of the Raven.txt for reading as F. For each line in F, if the pattern is found in the line, I want to print the line, but I want to strip off the new line from the end. Now, each line that I read from the input file ends with a new line character. If I leave that new line character in the line, well, print is going to end up displaying the new line character from the line and then displaying another new line character, so everything would come out double spaced. By using strip, I'm going to eliminate that double spacing. And let's see what we get. Okay, we got a lot of lines containing Raven, all right? The title of the poem, there stepped a stately raven, ghastly, grim, and ancient raven, quoth the raven nevermore, blah, blah, blah. Okay. Since we're looking for a literal string, we could have just done a string.find. But what if we're looking for a more general pattern rather than just some literal string? For example, let's try out these meta characters, the caret symbol. Now this symbol has a variety of different names. I prefer to call it the caret, which is C-A-R-E-T. It's also called the circumflex or the hat or the up arrow or various other names. And it matches the start of a string. So if I were to say, let me get back my pattern here. Let's change this pattern from Raven to caret the. Okay, so now we're looking for lines that begin with capital T, little h-e. And I'm going to read through this file again. We're going to end up displaying all of the lines that begin with capital T-H-E. And it turns out there's only two, all right? The title, The Raven, starts with a capital T, little h-e. And there's one other line in the poem, then this ebony bird beguiling my sad fancy into smiling. I should have memorized this at some time in my life, but I haven't. Okay, so these are the only two lines in the poem that begin with a capital T, little h-e. There may be other lines that contain capital T, little h-e elsewhere within the line. $sign matches the end of a string. So we could try looking for the pattern. Let's look for a double quote at the end of a line. Because it looks like we have several lines in here that end with a double quote. And there we go. So we have quite a number of lines in the poem that have a double quote as the very last character in the line. Okay, now another thing that we're going to do now that we're starting to introduce these meta characters, the caret symbol and the dollar symbol and various others that we're going to talk about, we're going to make our patterns be raw patterns. And the reason for that I will explain in more detail later, but basically when you specify that a string is raw, it causes the backslashed characters to be treated as literal rather than as special characters. Let me show you one really quick little example. If I say S1 gets hello \n world \n, this is a test. This is not a raw string. I haven't stuck an R in front. And consequently, within this string, each place where I typed \n is recognized as a new line character. So if I say print S1, when print displays the new line character, it's going to cause the cursor to drop to the beginning of the next line down. Hello world, this is a test, therefore comes out on 3 lines on my terminal. But if I say that S2 is a raw version of the same text, now backslash is just treated as an ordinary character. And the N following the backslash is also just an ordinary character. So this raw string consists of HELLO \n WORLD \n. In other words, it's just one line that happens to have some backslash characters in it. So because backslashes are used in regular expression notation, we're going to get in the habit now of using a little r in front of our patterns. Okay, so I showed you caret THE and double quote dollar. Here we're just using different examples. Lines that begin with a little f, lines that end with a little e. Okay. Remember that match only looks at the beginning of a string. You can accomplish the same thing as a match by sticking a caret in front of the pattern that you're looking for. So if I wanted to search for lines that begin with F, I can use as my pattern R and then caret F, and then I can use the search function rather than the match function, and it accomplishes the same thing as using the match. All right. Here on slide 17 are more regular expression special characters. We've talked about the caret and the dollar. Dot matches any single character, any character at all. So let's take a look again at my data. And let's see now. So I have trying to find something that would work well. Well, nothing is coming to mind, so let's see. Okay, here we go. Here is one way of using a dot. If I have caret, which matches the beginning of the line, and dollar, which matches the end of the line, then caret dot dollar means to match any line that only contains one character. Now, that one character can be anything. It can be a letter, it can be a digit, it can be a punctuation mark character, but the line can only contain a single character. Without using the dot, by the way, if I used caret followed by dollar immediately, that would look for lines that are empty lines. And so let me go back to our Raven poem here. Let me set, all right, I'm going to copy and paste this thing. And let me set my pattern equal to caret dollar. So now we're going to search through this file, the raven.txt, for all of the blank lines. And it turns out, and we can see this just from looking at the poem, there are a lot of blank lines in here between the various stanzas of the poem. So when I run this, I do get, it sort of goes flying off the top of my screen, but I do get a whole bunch of blank lines displayed. Now, I don't believe I have any lines that are only one character wide. If I say pattern gets caret dot dollar, that's not going to match anything. But if I say pattern gets caret dot 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 dot, okay, I'm looking for lines that are exactly 9 characters wide. I forgot my dollar. I'm looking for lines that are exactly 9 characters wide here. And I did that because I happen to know that that's how wide the title is. So the title is going to match. And apparently that's the only line in the file that is exactly 9 characters wide. Okay? So that's the caret and the dollar and the dot. Now, when you use square brackets mean to match one of the characters found between the brackets. And so, for example, if I say, let's look for the pattern ABC, what that's going to look for, I forgot R, but since there's no backslash in there, I don't really need the R, so we'll not worry about that. This says to look for lines that contain a capital A or a capital B or a capital C. And so we do find quite a number. We have a lot of lines beginning with and, which, because of being a poem, is capitalized. We also have here's B and here's C. So we do have a number of lines in this file that contain either a capital A or a capital B or a capital C. Upper and lowercase letters are distinct. So this pattern here, square bracket, little a, little b, little c, capital C, is going to match any one of those 6 possible characters. Now, we use the caret symbol to match the beginning of a string. It turns out that the caret has a second meaning if you use the caret as the first character inside square brackets. Basically, what it does is to invert the pattern. So when I say caret XYZ, what I'm saying is to match a character which is not one of these characters X, Y, or Z. Okay? And we'll see some examples of that. Since it's common to look for ranges of characters, you can use a hyphen or a dash in the square brackets to indicate a range. So if I do a search for square bracket little a dash little z, that means to look for any lowercase letter, any letter between little a and little z. Now this happens to work if you're on an ASCII character set, because in the ASCII character set, the little a and the little z are, the lowercase letters are sequential, starting from little a and going to little z. If you want to look for an arbitrary letter, whether it's either uppercase or lowercase, you can do a search for some character between capital A and capital Z, or between little a and little z. And you can flip those around. You can search for little a through little z or capital A through capital Z. If you do something like this, capital A dash capital Z, comma, little a dash little z, and your thought is that you're just using the comma to separate the two different ranges. Well, actually, the comma here is treated as one of the possible characters to match. So this notation, square bracket, cap A dash cap Z, comma, little a dash little z, means to look for a letter or a comma. All right, so don't put a comma in your regular expression unless you're planning to match a comma, or unless you're hoping to match a comma. The star is another special character, and it's named after some mathematician named Kleen, capital K-L-E-E-N-E, and it creates what's called a closure, which is basically like all possible combinations of whatever pattern occurs before the star. So the star does not, the star is not used all by itself. It's always used in combination or following some other character. So if I were to say A star, that means to match 0 or more sequential A's. So, in other words, an empty string, or an A, or 2 A's, or 3 A's, or, 1,000 A's. Any of those possible sequential combinations of A is what A star matches. And the most important case to remember here, because you'll be surprised if you forget, is that A star matches 0 or more of little a's. So A star will match an empty string. Let me show you an example that may surprise you. Here's my data again. And if I say for line in my data, if re.search for caret A star in line, if that's not none, then display to me the line that matches. Okay, so we're looking in these 4 strings here to see whether they begin with sequences of little a's, and the key here is A star can match 0 little a's. So which lines are going to match? Well, every single one of these lines begins with 0 little a's, and consequently all of these strings match that pattern, caret A star. Let me show you a little better example. Remember that our poem has a whole bunch of indented lines in it. Let me pull that poem forward again so we can look at it. Notice that it has a whole bunch of indented lines here. Well, I can match optional indentation by saying space star. Space star matches 0 or more spaces. So let me get back my for loop that goes through this Raven file. All right, I'm going to make a copy of that thing. Let me use as my pattern caret capital A. And we're going to look for all of the lines that begin with a capital A. We have 3, all right? As of someone gently rapping, and each separate dying, and my soul from out that shadow. So we've got 3 lines that begin with capital A. But if I search for a pattern of caret space star capital A, now I'm saying optionally indented capital A. That is, we're looking for lines that begin with 0 or more spaces. All right, space star means 0 or more spaces. And then after that optional indentation, we're looking for a capital A. And let's see, we probably are going to get different lines now. Yeah, we get a whole bunch more lines because in addition to the 3 that we got before, where the very first character on the line was capital A, we also have many indented lines. So here we've got distinctly, I remember, and the silken, and so faintly. We've got a whole bunch of lines where the first non-white space, the first non-space character on the line is a capital A. Okay, so remember that about the star. Now, I said that most that non-regular expression characters are just treated as ordinary characters. All right, so if I say pattern is OW, and then I search for my pattern, I'm literally looking for a little O followed by a W. I'm not sure what I might find. Okay, quite a number. I've got foul here. I've got sorrow. I've got throws. So I have little OW appearing a number of times. If I want to look for an actual special character like a caret or a dollar or a dot, I can stick a backslash in front to match that. So let me look for a pattern of, and now I need to be careful to remember to treat this as raw because I want to look for a literal dot. I'm not using dot to match any old character. I want to do a search for a literal period character, and poems sometimes are, have a whole bunch of exclamation marks and dashes and whatnot. I'm not sure I'll find any periods, but let's see. Oh, yeah. Okay. So we have we've got nevermore over and over again in here with a period at the end of it. So I see that this would never have passed a freshman composition class because clearly you're supposed to have a comma between said and nevermore. Then the bird said, comma, nevermore. Oh, well, I guess Edgar Allan Poe has been dead long enough not to care about English professors. Okay, so here are a bunch of additional examples of these things that we've talked about. And what we're doing here is we're gathering up a bunch of these things into a list of patterns, and we're going to apply these patterns against all of these strings. We're using nested loops for this purpose. So for each pattern, for each word, we're going to search to see whether the word contains the pattern. And we'll end up getting a table from this. Now I have this stuff in a already typed into a code file, so let me copy and paste that so I don't mess it up. Here's my patterns that I'm using. And here's my data. And now for each pattern, for each word in the data, I'm going to search the word to see if it contains the pattern, and if it does, I'm going to display the matching line and the pattern that it matched. Okay, so we got a ton of output. Let's scroll backwards. In my data, one of the strings is an empty string. And consequently, $$ matches that empty string. So I get told that the pattern $$ is found in the word, and what we have there is the empty string. $$ matches this string, the second string in my data that has just one character in it. If I then do a search for a capital letter, well, this time I have 3 matches, okay? Because if I'm searching for a capital letter, the word A matches. The word AB also matches, okay? So A is a match, A, B is a match, and A2 is also a match because I'm looking for a capital letter. I'm not requiring everything to be capital letters. Also, or in the next pattern, I'm looking for a digit character. The way that you look for a digit character in regular expressions is with the pattern square bracket 0-9. Now, in the ASCII character set, the digit characters 0 through 9 are simply an ascending sequence. I'm confident that you don't know this, but it turns out that the character 0 is the 49th character in the ASCII character set. Its character code is 48. And so 1 is 49, 2 is 40, 2 is 50, etc. And so the 0 through 9 characters are in ascending sequence. And I can look for any digit by using that pattern 0-9. Okay. So A2, capital A2, is a match of 0-9. 2A is also a match of 0-9. 077 is a match of 0-9. Now, my next pattern that I'm looking for is, notice I'm using 2 sets of square brackets here. I'm looking for some character between 0 and 9, immediately followed by some character between little a and little z. The font makes it appear as though there might be a space in between these square brackets, but there is not, okay? So this is 0-9, immediately followed by A-Z. Consequently, this is going to find all of the strings that contain a digit immediately followed by a lowercase letter, and we only have one such string. All right, so 0-9A-Z only matches 2A. Now, the next pattern that we have is 0-9 and then caret A-Z. Caret means not, so this is going to search for one-digit character followed by a non-lowercase letter, but notice that there's a star after that. So I said a non-lowercase letter, but actually, because of the star, it means 0 or more non-lowercase letters. And this pattern here, A2, is a match because it does contain a digit, that's the 2, and the digit is followed by 0 or more things that are not lowercase letters. All right, the end of the line is 0 non-lowercase letters. It might startle you that this pattern is a match, 2 little a, but actually that's okay because we have a 2 followed by 0 characters that aren't lowercase letters, and then after the 2 and the 0 characters that aren't lowercase letters, we happen to have a lowercase letter, but that's fine. Similarly, this pattern here, 077, well, I have a digit, 0, and that's followed by 0 or more things that aren't lowercase letters. So there again, that's a match. Okay. So, pressing on here. The next pattern that I'm looking for is caret question, caret dot. A caret. Backslash question, backslash dot. And so the backslash turns off the special meaning of the question mark and says, let's look for a literal question mark. The second backslash turns off the special meaning of the dot and says, all right, let's look for a literal dot. So we have to have a literal question mark followed by a literal dot. And we do have exactly one string that matches that. We do have one string consisting of a question mark followed by a dot. Now, this last one here, dot star, may seem a little tricky. But remember that dot matches one character. Dot star, in any one character, dot star means to match 0 or more of any character. And consequently, dot star is going to match all patterns, regardless of what they contain. Dot star does match an empty string because the empty string contains 0 characters. Dot star also matches capital A or question mark dot or, anything. So dot star matches any amount of any characters, including no characters at all. And that's why dot star matches every single string in my data. Okay, and so there's the same output that I displayed in my shell. Here are some more examples. In this first example here, we're looking for any sequence of digit characters, including no digit characters at all. In the next example, notice that we're using the 0-9 pattern in square brackets twice, followed by a star. Now the star modifies the meaning of the second square bracket range. So the meaning here is that we're looking for one digit for sure, and that may be followed by additional digits, 0 or more additional digits. In this next example, this time in square brackets, we're looking for a plus sign or a minus sign. We have to have either a plus sign or a minus sign, followed by one digit, and then optionally followed by additional digits. Now, I notice that there's a quote mark missing from the end of this example. So if you tried this, you would have to add that additional quote mark. Why do we have the backslashes in front of the plus and the dash? Well, plus, it turns out, and we haven't seen this yet, plus is also a regular expression meta character, and dash itself is a regular expression character used within the square brackets to imply a range. So we're saying we want to look for either a literal plus or a literal minus, followed by one digit, optionally followed by additional digits. One thing you can use regular expressions for is to validate patterns. For example, we know that the rule for a legal variable name or a legal identifier in Python is that the first character has to be either an underscore or a letter, and additional characters, if any, have to be either underscores, letters, or digits. So this pattern here will match a legal variable name. The first character here in this set of square brackets has to be either an underscore or a lowercase letter or an uppercase letter. And then there may or may not be, notice the star, 0 or more additional underscores, lowercase letters, uppercase letters, or digits. Now, dot star, dot matches any one character. The pair of characters dot star matches 0 or more of any characters. So let's imagine that we were searching a string to see whether it contained all of the lowercase vowels in sequence. This pattern says to look for a little a, followed by any number of characters, including possibly no characters, followed by little e, followed by any number of characters, and then I, and then o, and then u. So in other words, this would match a string if the string contained little a, eventually followed by little e, eventually followed by little I, eventually followed by little o, eventually followed by little u. Okay? In this last example here on slide 21, we're looking for lines that begin with something that is not a little x. Notice that we're using both different meanings of the caret symbol here. At the beginning of the pattern, the caret symbol means to match the beginning of the line. As the first character inside square brackets, the caret means to match a character that is not one of the specified sets. So we're looking for something that is not an x. And in fact, we're looking for any number of those things that are not an x. This pattern has a little bug in it. The intention here is to look for, is to match a string if it doesn't contain any x. We actually would need a $sign here at the end for that to be successful. In other words, if we added the $sign here, we would say we're saying we're looking for lines that begin with non-little x's all the way up to the end, an end by adding the $symbol. Here we're going to take a look at some examples, similar examples found in the document, the raven.txt. And I have this stuff in a file that I can copy and paste. So the patterns that we're looking for are any one of these 5. Empty strings, or strings that end with a question mark. The question mark is a regular expression special character, so we're putting a backslash in front to indicate we're looking for a literal question mark at the end of the line. Here's our A, E, I, O, U example with dot stars in between. In this fourth pattern, we're looking for the literal string, wrapping, R-A-P-P-I-N-G. And then in the final pattern here, we're looking for raven, but the R can be either a lowercase r or a capital R. So we're going to search through each of these patterns, one pattern at a time, by looking in the raven.txt for lines that match the pattern. So let me copy and paste that loop code over. This counter variable here is going to keep track of the line count where these lines occur, so that when we display the matches, we'll know which lines are matching. Okay, so let me paste that in. Okay, well, we got a lot of output, so let's go back and take a look at it. So our first pattern is we're looking for blank lines, and there are many blank lines in this poem, as we've seen, separating the stanzas of the poem. So we have a blank line at line 1. Now, the counter here is counting from line 0. The title is actually line 0, and then there's a blank line below the title. Then we have the name of the author as the sub 2 line, and another blank line as the sub 3 line. So we have a great many blank lines in this poem. When we get to this next pattern, looking for A, E, I, O, U in order, again, there are quite a number of lines in the poem that satisfy this pattern. So here we have, and each separate dying ember wrought its ghost upon the floor. Here's a A, followed by an E, followed by an I, followed by an O, and a U. So this line does have little a, little e, little I, little o, little u in that order. Now, there are lots of other little a's, little e's, little i's, little o's, little u's in this line, but we don't really care about those extra ones. We're just checking the line to see whether somewhere it contains a little a, followed by a little e, followed by a little I, followed by a little o, and a little u. And that's true of all these other matching lines as well. Okay, so there's the A, E, I, O, U's, quite a number of lines. The next pattern we're looking for is wrapping. Oh, by the way, I guess the very first pattern we were looking for was empty lines. Oh, we did see those. Okay, we looked for empty lines and we found a whole bunch. We looked for lines that end with a question mark. I don't think we found any lines that end with a question mark. Right. We didn't find any lines that end with a question mark because if we look at the actual poem, there are double quote marks following the question marks. So if we look in here, we do have sentences ending with a question mark. Like here, Lenore, but there's a double quote after it. So the question mark itself is not quite at the end of the line, and hence we don't have any matches. Okay. So that pattern didn't match at all. All right, so then we've got the A, E, I, O, U, and then we've got wrapping. We've got 2 matches for wrapping. Gently wrapping. Gently you came wrapping. And then we have a bunch of lines that contain raven. And I think all of these... Okay, it turns out actually every one of these has raven with a capital R. Oh, except for here, notice that we match craven, which happens to contain the 5-character sequence raven, with a lowercase r in this case. Okay, so that's our first round of examples of regular expression special characters. Okay, in this next lecture, Regular Expressions Part 2, we're going to take a look at what are called, well, it's sort of a combination of what are called the extended regular expression meta characters, as well as some Python-specific regular expression characters. I'm going to skip these couple of review slides. So we've talked about caret for the beginning of line, dollar for the end of line, dot to match any character, star to extend a specific character to 0 or more occurrences of that. And we've also taken a look at square brackets to match one of the characters in the brackets, or one of the characters in a range if you use the dash, or one of the characters that is not within the square brackets if you use caret right inside the square brackets. And there are more of these regular expression characters. So let me show you the 2 slides worth of additional regular expression characters we can use in Python, and then we'll sort of hastily go through a whole bunch of examples. So vertical bar, well, I'll just highlight the whole thing here. Vertical bar means or. And so if I have some string S1 and then a vertical bar and some string S2, what that means is that a string is going to match if it contains either the substring S1 or the substring or the substring S2. You can use parentheses for grouping. Let me show you why that matters. If I say as my pattern, hello or goodbye with the vertical bar, then that pattern would match a string if the string contained within it somewhere either HELLO in sequence or GOODBYE in sequence. Now, what if you were interested in matching a line that started with either hello or goodbye? You might be tempted to say pattern gets start with hello or goodbye. But here, unfortunately, it turns out the vertical bar has lower precedence than the caret. So this doesn't say look for lines that begin with either hello or goodbye. What it says is to look for lines that either begin with hello or contain goodbye anywhere. Here's where the parentheses come in. If I say pattern begins with either hello or goodbye. All right, and so I can use the parentheses here to indicate that either hello or goodbye are the 2 possibilities that need to be at the beginning of the line. So that's what the parentheses are about. Now, some Python-specific things that frankly I personally tend to avoid because they're not universal in all contexts that use regular expressions. \B is used to mark word boundaries. \W will match a word consisting of letters, digits, or underscores. \W matches something that is not a word containing capital or lowercase letters, digits, or underscores. \d matches a single digit character, and \big D matches a character that's not a digit. \S matches white space, which is spaces, tabs, or new line characters, or for that matter, carriage returns, form feeds, various other kinds of special so-called white space characters, and then \S matches the opposite of that. We also have this special notation in Python that allows us to match if string 1 exists and it's followed by string 2, or to match if string 2 exists and it's preceded by string 1. Those are some pretty specialized matches. So that's one batch of extended characters. Now, let me cruise ahead to slide 13. Here are some other special characters. Star we've actually already talked about. Star modifies the meaning of the character in front of it to mean 0 or more occurrences of that character. This can be combined with the parentheses to indicate sequences of multi-character patterns. So if I say Pat gets hello in parentheses star, that means to match a sequence of 0 or more occurrences of hello. So I would match nothing because star will successfully match 0 characters. Or I would match hello, or I would match hello, hello, or hello, hello, hello. Now the hellos have to be exactly sequential. There can't be any spaces or punctuation marks in between. But this illustrates the use of the parentheses combined with the star. Plus is like the star, except that there has to be at least one match. So if I were to say, search for the pattern hello plus, then that would not match no characters. It will match an occurrence of hello, or an occurrence of hello, hello, or hello, hello, hello. In other words, there has to be at least one hello in the string in order to match. And then the question mark means to match either 0 or 1 occurrence. So if I were to say Pat gets hello, question mark, that would mean to match a string that contains hello either 0 times or 1 time. Okay. You can also use curly braces to specify that you want to match exactly X times. Now, I guess I would have preferred to use N and M here, or M and N here, because these have to be integer values, not floating point values. All right, so if I were to say pattern gets, and I just remembered to throw in my R. I don't really need it here, but a curly brace 4. Okay, that means the same thing as matching A. I have to match exactly 4 A's. Or I can say pattern, this time let me say A, E, I, O, or U. Okay, there's a pattern using square brackets that will match a lowercase vowel. And if I say 6 comma in curly braces, that means to match 6 or more sequential lowercase vowels. Okay? And then I can also specify the maximum number of matches that I want for repetition. Okay, so those are the additional so-called extended regular expressions characters that we have, shown here on slide 5, and additionally on slide 13. Now we're going to take a look at a ton of examples of these things. Let me Okay, so we're going to begin with these example patterns on slides 7 and 8 in this lengthy collection of data possible matches. So let me copy and paste that stuff. Okay, so here is my data, which is a long list of stuff. And then here are the patterns that I'm going to test all of those against. All right, and to do this, I'm going to use the same kind of loop that I used back in the previous lecture. For each pattern in the list of patterns, and for each word in my data, test to see whether the pattern matches the word. If the pattern does match the word, display the pattern and the word. So we're going to get lines of output for each pattern that does match a certain word. And the output is quite long, so let's back up and take a look at this bit by bit. All right, so our first pattern looks like A vertical bar B. And that simply means to look for either a little a or a little b. So this line, yes, a or b, certainly matches because it does have an a or a little b. This next line has a little a or a little b. This next line has a little b. It doesn't happen to have a little a, but we don't care because we have a little b. Here we have a little a, no little b, but that's okay. Then we have a little a in cat, a little a in A37, a little a in underscore AB, a little a in question mark, in AAA, and also a little a in a backslash. So all of those patterns, all of those lines do contain either a little a or a little b. Now the next pattern, and this is actually not one of the patterns shown here, but it is a pattern shown in the example output, so I wanted to include it. Often people get confused and think that, okay, I'm going to use vertical bar here for or, and I want to look for either dog or cat. But for some reason, people often get confused and put those words, dog or cat, or both, in square brackets. Remember, though, that square brackets means to look for one of the characters, not for the sequence of characters. So when we say square bracket dog, we're not looking for dog. We're looking for a little d or a little a little d or a little o or a little g. And then the vertical bar also means or. And this other set of square brackets means to look for little c or little a or little t. So the upshot is that this pattern is not looking for dog or cat. It's looking for little d or little o or little g or little c or little a or little t. So in other words, any string that has any one of those 6 possible characters, D, O, G, C, A, T, is going to be a match. Well, this string has an O in it. This string has an A in it. This string has an A in it. This string has an O in it. An A. Now, the string dog certainly contains a D or an O or a G, and the string cat certainly contains a C or an A or a T. Space DG does have a D in it as well as a G. GT has a G in it. A37 has an A in it. Underscore AB has an A in it. So we're getting a lot of matches for this square bracketed form here, because we're looking for any strings that have any one of these 6 characters. Now, if I did want to look for the string dog or the string cat, it would be appropriate to enclose those in parentheses, and this enables me to look for the 3 characters DOG or the 3 characters CAT. And all of the matches here for this pattern. Okay, so dog obviously contains DOG, cat contains CAT, my dog has DOG, dog has GOG. Most of these have DOG, but not cat. I don't actually need the parentheses to look for dog or cat. I can just leave those out and look for dog or cat, and so here we get the same matches. D plus means to match one or more digits. Okay, the backslash D means to look for a digit, and the plus means to look for one or more digits. And so A37, 37, those are the only strings that we have that contain a digit. Here we're looking for one or more words. And remember that a word, let's go back and see this, is any single word character, that is a letter, a digit, or an underscore. Okay, so we have a ton of matches for word characters because a tremendous number of these have either a letter or, either an uppercase letter or a lowercase letter or a digit or an underscore. All right, so we have a ton of matches for those examples. All right, if we're looking for frog followed by dog, we've only got one match. And if we're looking for frog preceded by dog, we've also only got one match. If we're looking, here we're looking for frog followed by dog with optional characters around dog. Okay, so this is not quite the same as looking for frog dog. We're looking for frog followed by dot star means any number of characters. Dot star means any number of characters. So we're looking for frog followed by optional characters and then dog and then optional characters. So here we have frog followed by optional characters followed by dog. And likewise here, frog followed by optional characters and dog. Here we have frog followed by optional characters, because remember that dot star will successfully match 0 characters followed by dog. Okay. Backslash W is looking for a literal period character. So we match the 3 patterns that have a literal period character in them. Backslash question mark is looking for a question mark. Backslash is looking for a backslash character, a literal backslash. All right. Okay, and then here we have examples of the star plus question mark and square bracket forms. So I'm running out of time, so I don't think I want to walk through every single one of these. But let's look at this one. This example here, all right, I've got backslash question mark in parentheses, and then curly brace 2 means that I want to match strings that contain exactly 2 side-by-side question marks. Now, it's possible that the string contains, 3 or 4 or 5 or 6 side-by-side question marks. that's fine. I only require that there be two. I'm not specifying that there can't be more than two. But down here, I am specifying a maximum number of matches of the dog name Barfy here. I want to match strings that contain either 2 consecutive Barfies or 3 or 4 consecutive Barfies, but not more than 4 and not fewer than 2. It's possible to put together, just as we put together a pattern to match valid Python identifiers, we can put together a pattern that matches valid floating point numbers. This turns out to be extremely complex because this little pattern here is looking for an optional sign, okay, either a plus or a minus or nothing, followed by 0 or more digits, followed by a decimal point, followed by 0 or more additional digits. So the theory here is, okay, we're looking for an optional sign, and then digits and a decimal point and digits. Now the problem is that because we're using the star, we could have 0 or more digits and then a dot and then 0 or more digits. It is not true that dot all by itself is a floating point number, and yet this pattern would match dot all by itself. Another shortcoming of this pattern is that it doesn't account for exponents. A valid floating point number in Python can look like 1e5. All right, even though there's no decimal point in 1e5, that is actually equivalent to 1.0e5, which is 1.0 times 10 to the 5th power. So writing a regular expression pattern that matches all possible floating point number literals and that does not match anything that's invalid turns out to be really, really, really long, and later in this material as an example. All right, well, I'm going to call it quits there. Regular expressions are intricate, complex, incredibly powerful. It does take a lot of practice and experimentation to become familiar with them. And they can not only be used for searching for patterns, but they can also be used with other facilities for changing certain patterns to other patterns. Okay.